So earlier this morning, you heard many talks. You heard Jeremy talk about the Pi system in the greater technology landscape, followed by Jason Joel's talk on the overarching capabilities of the Pi system. And then asset monitoring, most recently by Gopal and Keith. This talk will mainly focus on the self-serve analytics capabilities of the Pi system. And hopefully we will walk you through how you can take that decision-ready data and apply it to your advanced analytic projects with Pi integrators. So we'll be jumping through some concepts around analytics. So let's take a moment to talk about what analytics means in the context of the Pi system. So the word analytics has been taken many forms as of late, and it gets thrown around very easily. So it can be something as simple as picking up a calculator and running some quick calculations or unit conversions. Or it could mean elevating your readings and measurements with a simple equation so you can add some scientific principles to it. Or the more recent abilities to look at visual or statistical correlations in your data, or to add machine learning algorithms. So this is in no way an exhaustive list. I just mention it quickly to basically highlight the amount of analytic tools and capabilities out there for you to use. And the sheer number of them can leave us with a bad case of analysis paralysis. So while we're walking through this presentation, let's keep that in mind. And I encourage you to think about the business value that you need to achieve in your business, and maybe keep an eye out for the tool or the analytic capability that can help you get there. So we have a plethora of analytic tools out there that we need to consider. And then we also have some potential risks to consider if we're going for those advanced analytic projects. So a natural question that might come up is, where do I start? If I may tweak that question for you just a little bit and start instead, where are the quick wins? So where are those quick, low-hanging fruits that we can get to easily? So I put this up there for a quick perspective. Think of a large-scale analytic project that you had to start. Traditionally, that requires a large upscale investment with the potential of recouping that investment at some later stage. I challenge you to think about this in a different way, where you start the project off a little smaller so you can accomplish it much faster, while at the same time keeping the business value coherent so you can turn a profit much sooner. You can then, of course, reinvest those profits into the next and then the next. In a way, your success breeds more success. And this is a very important point because for you, the user, this enables you to keep that stakeholder buy-in. But this is only the start, right? Because in order to make sure that your analytic project is successful, you want to make sure that you get a subject matter expert attached to the project from the very early stages. This is someone who is close to where the data is being originated from, so they can add a sense of reality and practicality to your analytics project. What this will also do is give your users, the people who will be using the results of your project, excuse me, some trust in what you're doing. Secondly, you want to make sure that there's some sufficient value in the projects that you're running. So you have that stakeholder buy-in. But it's not, the value isn't too large that you end up waiting for that benefit. And then lastly, since we've now shrunken the scope of the project, we want to make sure that we can tie it back to that larger corporate initiative. So the next thing you might ask yourself is, how do I get those quick wins? What do they look like? So let's look at what it might look like if you have all of your data in front of you in a way that's contextualized and easy to read and solves all your problems. So this is an example that we came up with. Think think in this example that we are wearing the hat of a plant manager who's responsible for multiple sites. In this case, for a power generation and distribution company. And we might be interested in selling back power to the grid. So we're trying to figure out what our current capacity factor is. So we can start here on the national site level and then dive deeper into a specific site as need be. So all the KPIs that you see on the screen are live, which means that there are live calculations going on in the background. So think about it for a second. This means that even before you have interacted with your raw data, it's already decision ready. This is a big point. Secondly, you have some metadata, like equipment model number. It may be a material number in your industry, to the right of the screen, just to add some more context to what you're seeing. And even though, like I said, this is live data, you can still scope in on a specific time by simply toggling back and forth on that time signature at the bottom of the screen. But you might be interested in a particular site. So we can start here and then dive deeper for further granularity. This is the Black Mesa site. This was one of the wind farms on the previous vision board that you saw. And from the get-go, you can see that there are various other calculations going on this site level. You can see equipment availability. You can see the capacity that you have. So going back to that higher level question we had asked ourselves, what's our capacity factor? You can see that right over here. I'm sorry, I'm smiling for the camera real quick. You can see that. You can see that right over there without any hassle. And then also on the top of the screen, you can see that there's a drop-down menu for assets. You can reutilize this same dashboard for all the other wind farms that you saw on the previous vision board. This is a very powerful tool because it gives you the capability of not only viewing your assets, but also giving you a seamless way to interact with all the other facilities that you have. So what if there was a specific time frame or important event in your processes that you wanted to monitor? Let's talk about what that might look like for the end user. So in this deep dive, we will be a plant operator. And maybe we're interested in figuring out what's going on with a particular turbine during turbine curtailment. Wouldn't it be nice if you can take all the turbine curtailments and look at them compared to each other? How much value would that give you? So that's exactly one of the things that PyVision allows you to do. You can search for a particular event of interest, either by name of asset or name of event. Over here, we're looking at we're searching for a particular event by event type. And then we can dive in deeper and look at all the attributes that are associated with that specific asset that we're looking at in that time frame. And then we can put them all on the right of the screen and get a lot of context visually. And then once you add it with your domain expertise, there's so much that you can uncover. So you can see on a high level how powerful this could be in the right hands. So let's take a step back now and open up the hood and see how the Pi system enables you to achieve all of these small wins that have big impacts. So you might be familiar with this site if you've attended some of the other presentations this morning and this afternoon. This is the overarching high-level semantic view of the Pi system. And when it comes to analytic projects, it really starts at the data collection itself. Because if you're like most companies that I've talked to at least, you have a bunch of data scattered all around your enterprise. Because you're not just collecting sensor data, operational sensor data, but you also might have metadata sitting in another team's relational database, for example. In most cases, folks are trying to collect this data manually. I've seen some folks collect data from pieces of paper and whiteboards, and if this sounds too close to home for you, I won't hold this against you, because we do understand that data collection, especially when you're collecting it from so many different sources, can be quite the complex process. And it's hard to keep track of where all this data is going. But if you can get all of this data together under one roof, that alone can be so powerful for the start of that analytics project. Even though it's not fully part of analytics, it's important enough nonetheless to mention here. And that's why we've created over 450 interfaces and connectors. So pretty much anywhere you have operational data, we can help you collect it, store it, and do so in a very meaningful fashion. Excuse me. Next, once you've collected all this data, you still need to make sense of it before you can run some calculations on it or add context or do those large-scale analytics projects that you're all here to see. So we need to enhance it and contextualize, and that's where asset framework and asset analytics comes in. Because the nature of the data that you're collecting is that it's not born into this world looking nice and pretty in your spreadsheets, or with ancillary data that allows you some additional context. The data that you're collecting kind of looks like, a string of alphanumeric values, like the VIN number of your car. And I don't remember the last time I referred to my car with my VIN number. So if you're collecting data from the plant floor, it might be OK if you're close to the data, you're a subject matter expert. But if you're trying to take that raw data and utilize it, broaden the scope of it across the enterprise, it just won't work very well. So you need a way to contextualize it in a way that's meaningful and make it human-friendly. And that's where asset analytics and asset framework come in. They make your data go from what you see on the left-hand side of the slide to something that we all can interact with more easily to the right. Another very important thing that asset framework, and more importantly, asset analytics allows you to do is it enables rule-based calculations on a central level. So if you're trying to compare your assets across the enterprise, you need some sort of common methodology or a model if you want to be successful in this endeavor. In another sense, let's look at it this way. So you have plant A, B, and C. All of these plants are sending a monthly performance report to headquarters. And each one of them is doing their own calculations at the plant level. One of them might be adding some additional variables just to be more thorough with their calculations. But the problem with that is at the other end of the spectrum, when someone is looking at that report, it will be very hard for them to trust the results or to be able to do an apples-to-apples analysis. That's why asset analytics and asset framework allow you to centralize all of those calculations. So you can use a formula one time and then call it out in other places where you need it. It leaves you with one version of the truth throughout the organization and with results that you can trust with minimum errors. Let me also briefly talk about event frames in the example. That's where Pi event frames come in. It sort of sits within the asset framework category, and we build upon our architecture. So event frames are basically give you the ability to earmark periods that you're interested in your steady stream of data that you're collecting. So say you have a turbine that you want to monitor its start, and then you want to compare that start time with a steady state operations. So you can very easily do that. Or you have a pump that is not working as it's supposed to, or it's giving you downtime. So you want to capture that time. You can not only do that with asset frameworks, but you can also get a overarching view of that asset. So you can see all of the attributes that are associated with them in that time frame as well. This can be really powerful when you, let's run that again, when you layer all the different assets and all of their different downtimes on top of each other. And you can see a visual correlation of what's going on with your processes. Then you can see the visual changes happening, and also if you wanted to train some algorithms, you can do that as well. And then, of course, you can apply your domain expertise to make the analysis even more fruitful. So we've talked about a few different things over here, so let's quickly recap. Firstly, since there's so many different types of analytic methodologies and tools out there, the best way to be successful is to keep it simple and aim for those low-hanging fruits by starting small. And then utilize the Pi system to contextualize your data and make it more user-friendly. And then centralize your calculations so you can have one version of the truth throughout the organization with minimum number of errors. And once you have that, then you can take your data and run those additional high-level advanced analytic projects, which we'll talk to you about now. And I'll invite Landry back on to talk to you more about that. Thank you.
So now I'm going to talk about how the Pi system can enable you to do your advanced analytics projects. And to set that sort of in context, if we briefly consider types of approaches you could take with advanced analytics, you could use self-service tools and provide those to your operations team. So you're kind of interactively applying algorithms to streams of data. And our partners enable that. You'll see them at the expo, Seek, TrendMiner, Falcony. These are some of the few. So I encourage you to check those out. So that's one approach. Another approach is you could just give the raw operational data to your data scientist to try to wrangle it and try to find some insights from it. And then thirdly, which is what you'll hear about at the rest of this talk, is you could have your subject matter experts in operations work alongside data scientists in the tool sets that they're familiar with to approach the project that way. And what we've seen with customers is when you do that, there's a little bit more trust in what comes out of the project just because operations is involved along the way. And to give you a quick story, I've been fortunate enough to work with some of our customers around their advanced analytics projects. I got to project manage actually a few of them. And there was one in particular that stands out in that we got on site and there was an ongoing project going on for some predictive maintenance on these large vehicles. And the project was ongoing for 2 months already. They only were able to get some of the data off of the vehicles, tried to do some training with it, and they just couldn't take it very far. They didn't understand the data. The data scientists didn't quite understand the data coming off the vehicles, and there just wasn't a lot to go on. And so we were there for 2-3 hours, and we're able to curate a data set for them and show it to them to say, is this what you need to start your training? And we showed one data scientist, and he waved over the other 8 or 9, and they were so excited you could see that they were starting to brainstorm right away the next steps, because really the data preparation was the thing that was in their way. And so what were they so excited about, really, is we just showed them this. Not the actual, this data, but the concept is the same. It was row column format, operational data, with some context on the top to label each of the variables or features, and that was it. Now there's some complex filtering going on underneath this to make the data trustworthy, but we'll go into that in a second. But that was really all they need. And similar with business intelligence tools, if you're going to approach a project with, you're reporting up to the business some operational data. We've had customers spend a lot of time doing that. I'll call out 2 that have given great talks. I encourage you to go look at them on our website. Centrica and Cimex both talked about how they could spend weeks or months just curating these reports, and now it's down to minutes or less. So back to the data scientists, they need this in the format just because the algorithms expect it or business intelligence tools expect it. It's not, you can't just plug in raw operational data. Why? Why is that? Omar hinted at it earlier. The data just doesn't come born naturally aligned. You may have some alphanumeric describing those streams of data. Common or communication failures come in. Your assets are not necessarily all the same, right? Maybe you purchased them 10, 20 years ago, and now you just purchased another, and they have to work. The ones that you purchased today have to work with what you've purchased previously. Maybe there's some data out of range that if you're an operator engineer, you would know. As a data scientist, maybe not. So cleaning this up is what is the problem. And really what you can do to accelerate that is kind of bring your data scientists and operations team together on a project. So how might you do that? Well, we've used this with a couple of customers already. It's not necessarily the only approach out there, but nonetheless, the ones that you'll see out there usually involve some iterative approach with these kind of data science projects. And let me just jump through this real quick. The phase one, discovery, that's when you're going to go look at all the data that you have that might support your use case. So if you're trying to predict maintenance, you're looking at all the possible variables that could go into that algorithm. And you might think you have enough to support it, but we've actually had customers that, for one example, they thought they had 2 years of data that would be applicable. Turns out, after looking at the quality of it, it's only really 1/3 of it that's left that's usable. So you find that out in sort of the discovery phase, and you have some hypothesis from operations to tell the data scientists, these are the features that you might want to consider. They go into the explore phase then, the data scientists, they try to train the algorithm on that data. They're really bound to that data, right? They can't get any more accurate than what the data has made available to them. Come back, show the operations folks, is it accurate enough? If not, you kind of cycle back. That's the iterative part. And then finally, the third phase is really implementation, where you have a live algorithm, you're pushing the most recent data to it. You might even be pushing up a kind of incremental bulk load of data to retrain it on maybe a weekly or monthly basis. So to support this and make it streamlined and not ask too much of operations, you really need a product that kind of wraps around this iterative concept. So how might that look? So our Pi integrator for business analytics is what you're seeing here. So let me call out that it's really web browser based. So you're interacting through it that way. There's no coding. It's all drag and drop. So there's no maintenance of scripts or anything like that to be had. And if you walk through, immediately you see that context that Omar was referencing earlier. We're kind of using the same data set here. So we're in the wind farm with some wind turbines, and we're selecting out GE05 here in particular. So the product inherits that from Asset Framework. It also inherits the measurements associated with that asset. So you have some consistency there. You can just drag what you want on the lower left corner here up into the middle to shape the data that you're going to send over to your data scientists or your business intelligence tool. Finally, you don't have necessarily one asset. You want probably to use the data coming off your fleet of assets. And so you can do some complex filtering by using an asset template that's, again, based in Asset Framework. We're picking the wind turbine asset template here. So now you have all the wind turbines that abide by these measurements. And so you have standardization and normalization across the data set. Moving from there, the next step, you click forward and you get your row column format now, and you have some ability to augment some of this by adding, for here, we added the day of the week, or maybe you want the day of the year. You're trying to correlate with weather patterns that exist in another database. But you can append that to the data set. You can also do some filtering. So we have some basic filtering as well as some more complex filtering around event frames. So if we dig into that one for a second, you really just leverage the event frame template, again, back to earlier from Omar in the self-service analytics portion of the talk. We're just selecting out wind curtailment. It could be anything else. Maybe you want to look at the startup events or steady state events. But you get all the continuous stream of data, and maybe you just need the part that's a wind curtailment. So you can merely just select that as a filter option. And then you get some quick preview of all the events that are associated with that. Now, that doesn't stand alone. You can append more. So something simple as a numeric template. So maybe we don't want temperatures below 0 Kelvin, and so we're going to filter that out as well. And so you can quickly see how, again, this is clicking through, drag and drop, no coding here, and you're just assembling some filters to clean out the data. So to recap, in that discovery phase, we're applying some context from Asset Framework. We have some alignment on the data enabled by the integrator. We have some normalization due to some templates in Asset Framework. And then we've filtered on particular events and filtered out some erroneous temperatures. And so you're left with that. Now you want to push out the data. You know, push it to a platform or tool set that your data scientists or business analysts can use. So we integrate into a variety of them: Amazon Web Services, Microsoft Azure, some of the Hadoop components, as well as SAP HANA. And so we can do a bulk upload for that first discovery phase where you're going to train on the algorithm. And then once you have your algorithm that's accurate enough, we can incrementally push out data to support retraining. So that's that kind of schedule view. Again, a few clicks and you're publishing. Now, what about that middle phase, the explore phase? So you're iterating away. How do we reduce the time for that subject matter expert? That, you know, we come back, the algorithm is not accurate enough, so we need more data, different types of data. So here we have a list back into the Pi integrator for business analytics. We have a list of all the views, so I've selected the one that I was just showing you. And from there, a few clicks, I can edit a copy, and I've started right back where I originally had the data view defined. Finally, on that implementation phase, what parts of advanced analytics platforms do we plug into? So we can send that align data to a data warehouse for a business intelligence tool to pick up. We can push that same data set to a data lake where you can do some training on the algorithm. And then when you want to send the most recent data to your live machine learning algorithm, you want to send it based on the most recent data coming into Pi, we can stream that to a messaging hub. So some takeaways. Omar showed you how we can enable self-service analytics for the operations team. You have data in context. You can drill into it and drill back out quickly and leverage the domain expertise of your operations team to drive quick value. You can also scope those advanced analytics projects in a smaller way and approach it iteratively to de-risk advanced analytics projects with our Pi integrator, so bringing subject matter experts from operations and data science teams together. And the kind of crux of that is we're enabling this via contextualization and normalization within the Pi system. And so depending on who you are, if you're an engineer, operator, on the operations side, go check out Pi Vision at the Product Expo. Really experience what it's like to see the data in context a little bit more, how you can drill in and drill out. You can do some ad hoc trending. That's more of the newer capabilities. So go experience that. If you're a data scientist, go see what that output might look like further, what filters could happen on the data, or even what particular components we actually integrate into, and see if those are the ones that you're using today. And if you're more on the business side, just please talk to our customers. That's really what it's all about. Tomorrow is an industry track where customers will be sharing their stories, and so just learn what they've done with the Pi system to generate value And so with that, I sincerely thank you for your attention. I know it's late in the day. You've seen a lot, so really appreciate it.